In this lesson, we're going to explore cubic and power functions and their graphs. So let's start with the cubic parent function, which is y equals x to the third. So if I made a table and tried to figure out some points that were on this graph, I might start with -2. Well, -2 to the third power is -8. -1 to the third power is -1. 0 to the third power is 0. 1, 1, and 2, 8. So if I graph those points, -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, 1, and then 1, 2, 3, 4, 5, 6, 7, 8. 2, +8. So when I graph this, it does just a little squiggle there in the middle. That is your cubic function. That's the parent function. The domain of this function is all real numbers, and the range of this function is also all real numbers. And those two things are never going to change despite any transformations that might happen. All right, let's talk about what makes a function even or odd. An even function, the highest exponent is going to be even. The end behavior of your even function, both arrows are going to go the same way. So it's either up, up, or it's going down and down. Those would be our even functions. To be an even function, it has to have a line of symmetry at x equals 0. If the line of symmetry is elsewhere, it might have an even degree, but it's not an even function. So let's look at a couple of examples. Let's say we take a graph that looks like this one. Okay. Notice the ending arrows are both pointing the same direction. The line of symmetry is x equals 0. So this is an even function. We could take this function. Let's see. And let's say we drew this. So notice both arrows are pointing the same direction, has the same ending behavior, and there's a line of symmetry through x equals 0. So this is also an even function. Let's take another one. Let's say my graph looks something like that. Now, the arrows are pointing the same direction, so this function has an even degree, which means it's an x to the second, x to the fourth type of equation. But does it have an axis of symmetry at x equals 0? No. So that means it's not an even function. So there is a difference between having an even degree and being an even function. To be an even function, it has to have this line of symmetry at x equals 0. All right, let's talk about odd functions. Again, I can have an odd degree to a function, but to be an odd function, these are the characteristics we're looking for. The highest exponent is going to be an odd number. Your ending behavior, the arrows go opposite directions. So maybe it goes down, then up, or it might go up first, then down, but they go opposite directions. And an odd function has a point of symmetry at 0, 0. So if it's an odd function, it has to go through 0, 0. It can still have an odd degree, but it's not an odd function unless it goes through 0, 0. So here's an example of one. So notice if I were to flip this around, it would be the same thing. So it goes through 0, 0. Ending arrows are pointing different directions. This is an odd function. If I could take this one, notice the ending behavior is the same, It looks like a mirror image in quadrant 1 and quadrant 3, and it goes through 0, 0. So this is also an odd function. Now if I took something like this, so notice that the ending arrows are going different directions, but did this go through 0, 0? It did not. So this is an odd degree, but not an odd function. And we could take another one. We'll say it does this. So notice on this one, the ending arrows are going opposite directions. It does go through 0, 0, but is it symmetric about 0, 0? So is quadrant 1 the same as quadrant 3? No, not really. So there's not that symmetry about the point 0, 0. So this is not an odd function. Now, the equation is going to have an odd degree, but this doesn't meet the qualifications to be an odd function. So usually when we give you your functions, we're going to ask you, is it even? Is it odd? Or is it neither? So obviously, if it's on the ones we did above, this would be a neither, because it's not odd, it's not even, it's not odd. These, same thing. These would be in the neither category. All right, let's talk about this end behavior. So we're talking about which way the arrows are pointing. So the end behavior this question is asking, as x approaches infinity. So in other words, as x gets bigger and bigger, what's y doing? So if I look at some of these graphs, if x is getting bigger and bigger and bigger, what's happening to the y value? Well, it's getting smaller and smaller and smaller. So we would say f of x was approaching negative infinity. Actually, on all three of these, all four of those. On this first one we did, as x is getting bigger and bigger and bigger, look what the y value is doing. It's getting bigger and bigger and bigger. So this one, y is approaching positive infinity. Now, how do I tell? Well, here's what we know. An even function, if it's a positive a value, so that very first leading term is positive, it's going up and up. If it's a negative a value, it's going down and down. We practice that with our quadratics. So for this even function, we can tell if a is positive, the end behavior of as x approaches infinity is going to be infinity. If it's negative, it was reflected, it's going down, that's approaching negative infinity. Now our odd degree functions have rules also. If you have an odd degree, that is the largest exponent is odd, and a positive a value, it's down and then up. Think about the cubic function we graphed at the beginning. Down and then up. Now, if the a value is negative, that's a reflection over the x-axis, it's going to be up and then down. So those come in handy. Let's take a look. The first one says y equals 2x to the third minus 8. The 2 is a positive. The degree is a negative. An odd number. So the degree, the highest exponent is odd. So it's a positive odd. So what is happening as x approaches infinity? Well, if it's an odd with a positive a value, f of x is approaching infinity because it's getting bigger and bigger and bigger. Let's take a look at the next one. Negative 11x to the third. So notice the largest exponent is odd, and it's got a negative leading term. So a negative odd is up, then down. So as x approaches infinity, when x gets bigger and bigger and bigger, y is getting smaller and smaller and smaller. So for this one, f of x is approaching negative infinity because it was going down. This third one, y equals 5x to the third minus 7x plus 8. So the highest exponent was odd. The leading term was positive, that a value. So we go over here to our positive odd. It was a down up. So as x approaches infinity, that's the right-hand side, f of x is also approaching infinity. So that's how we start to talk about the end behavior. Now on this page, we're going to be simplifying our expressions, our polynomial expressions. So some of this work might look familiar as something you maybe did in Algebra 1. So notice this first one, I've got this expression plus another. So remember, when you're adding and subtracting, you can only add and subtract like terms. They have to have the same variable, the same exponent. So this says negative 4x to the third. I do not see any other 4x to the thirds. So there's nothing to do with that one. Now, I've got a plus 2x squared, and I've got a plus 4x squared. So together, that's going to be 6x squared. For my x terms, I have a minus 7x and a plus 8x. So together, that makes positive 1x. And then this negative 1 doesn't have a like term to combine with, so it's just there. So we add and subtract the like terms. Next up, notice is a subtraction problem. Whenever you see a minus in front of the parentheses, we're going to distribute our negative 1 into the parentheses. So I've got a negative 6x to the third minus 2x plus 2. I'm going to do the same thing I did before and find my like terms to combine. So first I notice I've got 3x to the third minus 6x to the third. So that's negative 3x to the third. My next term I have is a negative 8x squared. I don't see any x squareds over here. So I think negative 8x squared is just going to stay where it is. Now this is a plus 6 and a plus 2, so they can go together. But don't forget, there's a minus 2x, and there's nothing to add it to, so it stays. And then we take our plus 6 plus 2, and we add that to the end. Notice my exponents are in descending order, 3, 2, 1, and that's how we like to list our answers. Just makes it easier to follow. So adding and subtracting. Be careful subtracting. You have to distribute your negative 1. Let's do some multiplication. So we've multiplied things like this before. We did a binomial times a binomial, but this time we have a binomial and a trinomial. So we're just going to distribute twice and combine like terms. So distribute and then combine like terms. Here goes. So first I'm going to take my 3x times everything. So that's going to give me 12x to the third plus 9x squared minus 6x. Now I'm going to distribute the negative 2. And to make things easier for me, I'm going to line up my like terms just to make it easier to add them together. So negative 2 times 4x squared is negative 8x squared. So I lined up my x squareds. Negative 2 times 3x is negative 6x. Line up those x to the first. And then negative 2 times negative 2 is plus 4. Now I'm ready to combine my like terms. 12x to the third plus x squared minus 12x plus 4. And there's my answer. So I think lining up the like terms makes it easier to combine them. To me, it's less confusing. Our next one, we're going to multiply, but we've got 3 things. So first, we're going to pick 2 of them, multiply them together, and then multiply by the third one. So let's do the first 2. We know how to multiply these. We've been doing this. X squared plus 3x, and then negative 2x minus 6. So that comes out to be x squared plus x minus 6. But that was only the first 2. I still have to multiply by x minus 4. So now we're going to treat this the same way we did the previous example. I'm going to distribute my x and get x to the third plus x squared minus 6x. Then I'm going to distribute my negative 4 and get negative 4x squared, negative 4x plus 24. So when I combine my like terms, x to the third minus 3x squared minus 10x plus 24. So it's just a little bit of work. Just be patient and multiply your way through one piece at a time. All right, this one. Now we know when it asks you to square something, we write it twice because you multiply that times itself. But this one's asking us to cube something. So in other words, I need to do 2x plus 3 times 2x plus 3 times 2x plus 3. So we're going to approach this one the same way we did the previous question. We'll just multiply the first 2 together. And then when we get this answer, times the last one. So I've got 2x times 2x is 4x squared plus 6x plus 6x plus 9. So I think I'm going to combine my terms in here. I'll move over. I've got 4x squared plus 12x plus 9 times 2x plus 3. So we're just going to distribute our 2x plus 3 into the parentheses. So 2x times 4x squared, that's 8x to the third, plus 24x squared, and then plus 18x. Now I'm going to distribute the 3. 3 times 4x squared is 12x squared. 3 times 12x is 36x. And 3 times 9 is 27. So I'm going to combine my like terms. I've got 8x to the third plus 36x squared plus 54x plus 24, or 27. So there's a little bit more to that one. We had to multiply the same number times itself 3 times. That's going to make this next one look pretty easy because I've only have a squared. So I'm going to do 2x times x plus 1 times x plus 1. So we're going to solve this one the same way we did in the previous unit. We'll do the x plus 1 times x plus 1 first, and then we'll distribute the 2x. So that's x squared plus 1x. And then when I distribute the 1, that's another 1x plus 1. So I have x squared plus 2x plus 1 times the 2x. So I'm going to distribute these and get 2x to the third plus 4x squared plus 2x. And that would be my answer. Now let's answer one more question on this page and we'll be done. So they've given us an equation, and they want us to tell the degree, the domain, the range, and the y-intercept. So first of all, the degree. The degree, remember, is the highest exponent. Now, they might not be in the right order, so be careful. Your degree is the highest exponent. So look at your powers. I've got an x to the third and an x to the fifth. This is a degree 5. So if you wanted to, you could rewrite it in the familiar form. And you can see the highest power is a 5. Now the domain. This has an odd degree function. So it's not an odd function, but it has an odd degree, which means if the leading term is positive, it's one of these down then up. So the domain, it does a little curvy. It might do this. It might have a couple of little bumps in it. But no matter how you slice it, it's the bottom's down and the top is up. So it's everything in between, all real numbers. And the same for the range. If I go bottom to top, it's going to cover everything. So all real numbers. The y-intercept, kind of like in our quadratics, the y-intercept is the constant at the end. Because if I put 0 in for all the x's, 4 times 0, 2 times 0, I end up with just the number at the end. So the y-intercept is that constant number at the very end.